Welcome back. So this is for the second part of understanding computer forensics, the workshop. This part is going to be a little more technical. This is going to be discussing our tools that we utilize and what the tools give us. Again, this would be the analyze portion that I've mentioned during the steps of investigation. This is us using our skills, using our experience, using our tools in order to analyze our data in order to make evidence. I want to reiterate that I've already mentioned in the first part about what is data? What is the data being collected and what is the data being analyzed? This is part of the list. It's not comprehensive. We have browser history, files folder created or deleted, photos, videos taken, saved, sent, deleted, and any form of communications, email, text messages, phone calls, utilizing social media, what happens during those interactions and what can we collect during those interactions. We also have information about our Wi-Fi and our networks. Like when you joined it, what did you search up while being in the network? What were you trying to do on those networks? So let's get started with our technical portion. We can further divide computer forensics, weirdly enough, into two parts. Our host-based forensics, which is basically collecting and analyzing data on individual computer systems. This is our laptops, these are our phones. This is the data, our files, our folders. These are actual physical devices that we interact with every day. And then our second one is our network forensics. This is investigating our network traffic and our session information. And both of them do have data, but data can be either volatile and non-volatile for host-based forensics for our computers, our laptops. And then data, on the other hand, for network forensics, is more volatile, more unpredictable, and only exists if we install the necessary tools and the necessary measures in order to log what happened, whether it be as verbose or not, meaning as detailed or not detailed. This is all up to us. So now I'm getting into the idea of volatile and non-volatile data. What does it mean that data is volatile? It means that data is fragile. It can easily change, whether it be booting up of the computer, or it could be changed in the sense that we didn't log enough details within our firewalls, because every time you trigger a firewall, that trigger will actually record your IP address. What were you trying to do? Why it was triggered in the first place? So if we don't log that critical system issues from our firewalls, from our intrusion detection systems, then the data doesn't exist, at least for network forensics. In addition, whenever we think of host-based forensics, we can actually point to RAM. I remember in elementary school personally, my teachers at the time, they would say, don't forget to regularly save your Word files. Well, I don't think it was elementary school. It was probably middle school. But either way, they keep on saying, remember to save your files. Remember to save your files, because if the power went out and you reboot up your computer, whatever you read that wasn't saved would have been wiped from the computer. And this is what I mean by volatile. It means that this is not saved information, and that easily booting up the computer, turning off the computer, or even updating the computer can change data, can change memory. And us also not being very detailed in what we're logging within our networks can change data, change memory, and change what evidence we have in order to bring to a court of law. And this is very important and very necessary to understand within computer forensics. So moving past that, let's just say that data does exist, that we do have all the data that we need, and so on and so forth. What now? What do we do with this data? We have so much of it. Like, how do I start learning about this data and start understanding this data? Well, we can use some common tools of the trade of computer forensics in order to further investigate and further understand, because it's not very easy to just take a bunch of files essentially from your computer or from your network logs and just look at everything. There are tools to either automate or expedite the process, but remember, these tools, whether it be existing or new, are validated to do this purpose. Some of the common tools that we see for either side of the forensics, like host-based forensics, we have log to time. Log to time basically is our time events a tool which can essentially tell us when certain files were downloaded, when were certain files executed, modified, and so on and so forth. We also have SleuthKit. SleuthKit allows us to recuperate a certain amount of data, whether it be deleted files or not deleted files, and sort of get an understanding, a perspective of what was on our computer. And one of the most common tools used that uses SleuthKit is autopsy, which we'll go into a little later as an example. We also have disk editor, meaning we can open our drive, our actual place where it holds all of our files. Actually, it holds the computer system in general. And we can actually go through piece by piece of the computer and understand what operating system are we utilizing, what's on this operating system, and so on and so forth. We also have SQLite browser, which basically would go through our localized database systems to see what browser history we have, what are we using Firefox for, what are we using Chrome for, and so on and so forth. And of course, this is not a comprehensive list. There are many other tools that are out there or are being created to help us for host-based forensics. On the other hand, we also have some network forensics tools that we can utilize. We have Wireshark, which I'll go a little more in depth later on. Wireshark is a GUI, or graphical user interface, that allows us to see actual network traffic going through our systems or through the networks. We have NetFlow, Netminer. Netminer allows us to actually see the stream of traffic and actually puts together streams of traffic so we can see what type of communications, who said what, who texted what, and so on and so forth. We have Squid, we have Snort. Snort is a way to implement rules within our networks and to log information. And again, all of this is not a comprehensive list. And there are other tools out there that are existing or being in development in order to help us with network forensics. But these are, in my opinion, one of the most common. If you say it out loud to another forensic specialist, they're going to be like, oh, yes, I understand what you're trying to do, or I understand what tool is doing, and so on and so forth. So let's see some example of these tools. So I mentioned earlier about autopsy. So this is a layout, a example image of autopsy. Essentially, as we can see here, we can learn a lot about our computers. We can see images, as I said before, images is basically our entire phone, the device, and we can see also the partitions of the device. So within computer science and computer systems, it's not just we use the entire memory space for just the user. We divide it up for things that the device needs, like an operating system, and stuff that the user needs. So we can see what volumes and what partitions we have on the image. We can also see that it tells us what type of files are on there. Some images, videos, audio, some other documents, recent files. We can actually have an organized manner in order to look at this data, this information, these artifacts, in order to make evidence. And these files will tell us, autopsy will tell you whether or not files were deleted, where the files were, how big the files are. And as you can see through this screenshot, you can see when files are modified, changed, accessed, and created, which all are very important in order to make that timeline. In another section, we actually get a lot of information about our browser history, what we downloaded from the internet, and what installed programs we have, and what we bookmarked, our cookies, and our web history, which are very important, especially whenever we have people searching up of how to do things. This we can recover quite easily. We also see what devices are attached. This is pretty important because we get to see if there was a USB, if there is some other form of evidence data that we also need to recover. We can easily find it through autopsy. We also have a certain section called keyword hits, which within forensics, we most of the time need context during our investigations. And if we have context, we can actually search through our entire device in order to find whether or not there are files that incorporate these words. Like, for instance, we have for kidnapping, like, how do I kidnap someone? I can use the keyword kidnapping or kidnap in autopsy, and they will actually go through the entire image and find every piece of information that involves this word. And so this is a very powerful tool, especially when you learn how to use it. It can expedite this process of finding evidence and also making reports and so on and so forth. Now, for our network forensics, I have Wireshark as our tool because whenever you start doing networking, you will be introduced to Wireshark first. So what does this tool show us? It shows us the number of packets that we've gained since the beginning, the start of starting this tool. We also get the time. So time here is in seconds, but we can actually re-manipulate time to be an actual date plus time, and so on and so forth. We are given IP addresses, even MAC addresses, which is very important. It can tell us what router we were on and where this packet was within our network. We're given what protocol was utilized. So a common way to understand what protocols are is whenever you go on the internet, you hear, you see in the beginning of our URL, HTTPS, which is a type of protocol in order to do browser interactions. So we can actually see that. We can see what ports are utilized, meaning if you were doing a specific action, like searching for a website, usually you would use port 80 or port 443, or if you were looking for a certain URL, you would use the DNS. You would use a DNS query in order to find out what URL it is. So ports and protocols are very important. And another important aspect is data. We're seeing what's actually being transmitted in real time from a user. And here you can see that the data being transmitted is called Network Working Group D. Waltzman. So we can actually see it within text messages and so on and so forth. And we can do statistical analysis within Wireshark itself to find what common IP addresses we're communicating with each other and so on and so forth. So this is also another powerful tool that is used within network forensics. We also have logging in order, we also have like logs in order to see other examples of like what is being violated and so on and so forth. So this is one tool that I find very important to discuss. So even though computer forensics, as you see, is a very powerful thing, and we recover a lot of information, there are still challenges that we face right now that we are still trying to solve. And one of them is data encryption. And a lot about encryption is that we need a key in order to unlock what's being encrypted. And if we don't have the key, how do we actually understand what's being sent or what's being hidden from us? Because our job is to do data recovery, but data encryption sort of prevents that recovery without a key. We also have another issue with cloud data. How do we access easily the cloud and so on and so forth? It's very hard. And as another thing is, as the internet becomes more widespread and more accessible to more people, we have a lot more information to go through, especially network data. And with our with users utilizing networks and utilizing the internet, when they don't understand that they're not supposed to do something, accidents happen, and even accidents be logged, and we have to go through and sort of understand from the immense amount of information what's an accident and what was purposeful. And that's another issue we're trying to face. And then, of course, again, we are the part of our domain is law. We have also multi-jurisdiction data storage. So if you were providing a service within the state of Pennsylvania, for instance, but all your data is in California, now it becomes an issue of going through that data for a Pennsylvania court case when all the data is in California. So you have that multi-jurisdiction issue that sometimes it impedes us from doing computer forensics the way that we need to in order to make the best version of evidence for the court to show the truth of what has happened. So the last part of this entire this entire workshop is basically our case studies. I want to go through and actually show you real life case studies of how forensics actually helped. And I find this very useful and very interesting at times of how things worked. So the first one is called the BTK killer, how we caught this person. So a little more about this case is that there was a serial killer that would murder 10 people from 1974 to 1991. This became a cold case after 1991, and the killer would periodically communicate with the police and leave notes within cereal boxes. And at one point, the killer would told the police, if I left a floppy disk, if I left something behind, like a floppy disk, you would not be able to trace me, and asked to not be traced, essentially, from the floppy disk. So he left a note on a floppy disk, and it was left with the police, and obviously computer forensics started. Some of the people, the specialists, the computer forensic specialists in this case, they went through the floppy disk and found some metadata that led to his actual identity. So it connected him to the crime. And at that point, he got arrested, obviously, and is now serving a 10 consecutive life sentence in prison. So this is a little bit of how computer forensics can help during a physical crime, which is great. Now let's talk a little bit about a crime that happened mostly on the internet. There was a user that went by the name Dread Pirate Roberts that hosted a website that allowed anything to be sold. You can think of it as the black market Amazon at the time. How it utilized both Bitcoin as currency. So Bitcoin utilizes heavy amount of encryption, which is very hard to break. And then they also used Tor, which is to host the website, and Tor is known to try to allow users to be anonymous while they're going through the internet and so on and so forth. So with these two things in mind, we now realize that the situation is a black market style Amazon trying to use encryption and not being anonymous on the internet in order to do things. So it became a little harder in order to find information and try to actually arrest the person hosting this website, the user, Dread Pirate Roberts. So at one point, the FBI found the actual person, their identity, Ross Elbridge, and his username and eventually his name. So how did forensics help? So At one point, the IP address for Silk Road was revealed during a coding error or something like that. Someone was able to recuperate that information. And then, because they knew the IP address, they were able to mirror Silk Road's server and gain internal data. And they were able to investigate these servers and investigate that internal data in order to understand who was actually behind it. At one point, they were able to match the internet usage between the user, Dread Pirate Roberts, and the person, Ross Elbridge. At one point, the FBI had an entire situation in which they apprehended Elbridge while his laptop was unlocked. And because his laptop was unlocked, computer forensic specialists, they were able to go through it and find that he was logged in to his Bitcoin wallet and also had a list of servers that were the exact same as servers for Silk Road. And they were able to use this evidence in a court of law of essentially taking down not only Silk Road, but also prosecuting Dread Pirate Roberts or Ross Elbridge. So that's the end of the workshop. If you want to learn a little more about forensics and CTFs, more specifically of how to incorporate the tools I was talking about and so on and so forth, you can go onto picoCTF and hit playlists to forensics and CTFs. Anyways, thank you. Bye-bye.